Habari gani? That's, hey, how's it going? In Swahili, which is the language that they speak in Kenya. So today we're going to be doing 10.6, secants, tangents, and angle measures part 1. Now, a secant is not a real thing. But a secant, however, is a real thing. So a secant, that's how you pronounce it, secant, is a line that intersects a circle in 2 points. This picture here has 2 secants in the picture, so secant J and secant K. And notice if I were to just take part of that line, like the part that's inside the circle, that would be a chord. So imagine it's a chord of a circle, but it's actually a line because it goes on forever and ever. Now it is a secant. Today we're going to go over 2 theorems that have to do with secants. Here's the first one. This first theorem says if you have 2 secants and they intersect in the interior of a circle, then you can tell what the measure of the angle is that's formed by the secant's intersection if you know the measure of some of the arcs. For example, in this picture here, you can tell what the measure of angle 1 is if you know the measure of arc AB and the measure of arc CD. If you take the average of those arcs, so you add them together and you divide by 2, or you add them and you multiply by 1/2. If you take the average of those 2 arcs, that's going to equal the measure of angle number 1. Now remember, vertical angles are congruent. Vertical angles are congruent. So if you look at the picture and you see an angle that is the vertical angle with angle 1, that's going to be right here. Those are going to be congruent. So angle 1 is equal to angle 1, and those angles are the average of the measure of arc AB and arc CD. And the thing will work with the other angle as well. So if you look at the number 2 angle, the vertical angle is congruent. That's going to be right here, that number 2. And the measure of angle 2 is the average of arc BC and arc AD. So that's the first theorem. Let's take a look at how we can use this theorem to solve some problems. Oh, by the way, if you want to see why that theorem happens and how it exists and everything, you can take a look at the proof. If you don't really care, then you don't have to. But if you want to see the proof, I left it here in the video for you, so you can pause it and you can look at the proof if you're curious. But we're going to move on to the first example problem. In this problem, we are solving to find x. How many degrees is x? Now, I don't know the measure of arc AC or arc DB, so I can't really find x yet. However, I could find the measure of angle y. And notice x and y are supplementary because they're on a line, they're a linear pair. So if I find the measure of angle y, I can just subtract it from 180 to get x. How can I find the measure of angle y? Well, our theorem tells us that the measure of angle y is the average of this arc, 75 degrees, and the other arc, 143 degrees. To take the average, you add them together and you divide by 2. So the measure of angle y is 109 degrees. Now to find the measure of angle x, remember y and x are supplementary, so I'm going to do 180 minus 109, and that's going to give me 71 degrees. That's going to be the measure of angle x is 71 degrees. I have one more example problem for you. In this one, we're trying to find x, but we need to set the problem up a little different. It's not going to be x equals something. It's actually going to be 110 degrees equals, because this is like the angle measure, so it equals the average of the 2 arcs. One of the arcs is x, we don't know what it is. The other arc is 97. So this is how we're going to need to set this problem up. 110 degrees equals the average of arc GH, which is x degrees, and arc KJ, which is 97 degrees. Now to solve it for x, I'm going to start by multiplying both sides by 2. So I'm going to get 220 degrees equals x plus 97 because I multiplied both sides by 2. Now I'm going to subtract 97 on both sides, and we get that x is equal to 123 degrees. All right, I've got 2 practice problems for you guys to try using this theorem. Here they are. Go ahead and pause the video here, give these 2 problems a try, and then you can check your answer. All right, for this first one, we're going to say x is the average of 47 and 116. In my calculator, I'm going to add 47 plus 116, and I get 163. Then I do 163 divided by 2, and that gives me 81.5. So the first answer is 81.5. For this next problem, I'm going to say 128 is equal to the average of the 2 arcs, which is x and 154. Then I have to multiply both sides by 2, and I get 256 is equal to x plus 154. And when I subtract 154 from both sides, I get that x is equal to 102. So the answer for the second part is 102 degrees. That's the measure of x. We have one more theorem for today. In this theorem here, we have 2 lines that are intersecting each other. One of the lines is a secant line. That's going to be this line right here. This is a secant line. And the other line is a tangent line. Remember, to be tangent, it has to touch the outside of the circle in exactly 1 point. If you have those 2 lines intersecting each other, the secant line and the tangent line, something very unique happens. It just so happens that the measure of angle 1, and angle 1 is going to be this angle right here. So the measure of angle 1 is going to be equal to half of the measure of arc AB. And the same thing happens on the other side. Angle 2 is this angle right here. The measure of angle 2 is half of arc ACB. Notice how they used 3 points to name that arc. Because it is a major arc, it extends more than halfway across the circle. That's why they used 3 points ACB. So the measure of angle 2 is half of arc ACB. We're going to use this theorem to solve some problems. All right, in this first problem, we are trying to find the measure of angle QPR. That's this angle right here, and our theorem tells us that this angle is half of arc PR. If arc PR is 148 degrees, we're going to divide that by 2, and then we're going to get the measure of angle QPR, which is equal to 74 degrees. So that's the answer. In this next problem, they're asking us to find DEF, this arc right here. To do that, we're going to start by finding this arc right here, and then we can subtract it from 360. To find the measure of arc FD, I already know the measure of angle FDC is 64 degrees, and the arc is going to be twice as big. So if this angle is 64, then the arc is going to be 128 degrees. So that's the measure of arc DF. Now to find the measure of arc DEF, we have to do 360, because the entire circle would be 360, minus 128, and that's going to give us 232 degrees. So the measure of arc DEF is 232 degrees. All right, I have got 2 practice problems for you guys to try. These are the last 2 problems for today, so go ahead, pause the video, take your time in solving these last 2 problems, and then you can check your answer. All right, so these are the answers. You can keep watching the video if you would like me to walk you through an explanation of how I got these answers. If you don't need to watch the explanation, then you are done with this video. Go ahead and submit your notes on Canvas and have a great rest of your day. This first one here, they're wanting us to find the measure of arc JLK, so that's going to be this arc right here. We know that it's going to be twice as big as the angle, so I'm going to do 116 times 2, and that's going to equal 232 degrees. That's the measure of arc JLK. For this second one here, they told us that the measure of arc QTS is 238 degrees. So we can use the fact that the entire circle is going to be 360 to find the measure of arc QS. If we do 360 minus 238, we get 122, and that's going to be the measure of this arc right here. So QS is going to be 122. Now they want us to find the measure of the angle RQS. So this angle is going to be half of the arc. So we can do 122 divided by 2, and we get 61 degrees. So 61 is the measure of angle RQS. Alright guys, great job today. That is the end of this video. Remember to submit your notes on Canvas and have a great rest of your day.